Hey everybody, it's Wojo. Thanks for coming back to look at another algebra video. Today we're going to be looking at solving quadratics. And so today we're going to be solving equations that have an x squared in them. Up to this point we've only been solving equations that had x's in them and not x squares or x to the thirds. And that's going to require us to have some different solving methods. So this will be the first time you'll see solving quadratics. You have solved before. You've solved equations like 2x plus 4 equals 8. And remember, the idea of solving is just to get x by itself, so we know what number has to go in for x, so that way 2 times this number plus 4 equals 8. We learn solving techniques like farthest away, undo, undo, and getting x by itself. But remember, when you're solving, your end goal is to say what the x, the number that's being represented by the letter x, what it's equal to. So when we solved before, we would undo, get x by itself, and in the end figure out that in this case x is equal to 2, because 2 times 2 plus 4 is equal to 8. The problem with that kind of strategy is it doesn't work for x squared equations, especially if there's another x in there, because when we say let's get x by itself, do we get this x by itself or this x? And it's harder to solve with x squared. It's a more complicated problem. It's used to model more complicated physics and stuff problems. So we do need another way to solve it. So today we're going to look at how to solve quadratics by factoring. So we're going to use that same skill that we used last week to factor these trinomials into smaller or simpler problems. So without spending too much time just talking about what we're doing, let's actually do a problem. Our goal, solve x squared plus 10x plus 16 equals 0. So can you think of a number x? So think of a number that could go in for x, that if you took that number and times it by itself, that's what squared means, plus 10 times that number plus 16, your final answer, if you did all that addition, would be 0. One of the things you should know, and there's going to be lots of small detail stuff that we're going to talk about, hopefully I don't get too much detail that it's kind of confusing. But one of the things you should know is if there's an x squared, we should expect up to 2 answers. And so normally when it was just x, just a plain x, there was only one answer. On x squared equations, there could be 2 answers. So we're going to expect 2 answers. What we're going to do with this solving method today is we're going to factor or break this down into its parts so we can solve it easier. So if you need to, go back and look at the factoring video we put out. If you feel like you remember how to factor trinomials, then this shouldn't be too bad. So again, trinomial, 3 pieces. So I know from our last video that a trinomial can be factored down into a binomial times binomial. So I'm going to take x squared plus 10x plus 16 and write it a different way, write it as binomial parts. So again, to get that x squared, remember we need an x here and an x here. That way when we multiply those out, x times x is x squared. And then we talked about this idea of factor x. Can we think of numbers that multiply to 16, that last number, that would combine to 10? So can you think of numbers that multiply to 16? So think of those first, and then 4 times 4 would multiply to 16, 2 times 8 would multiply to 16. We need the combination that would combine to 10. So is it going to be 4 and 4, or is it going to be 2 and 8? It's going to have to be 2 and 8 in this case. And so what we can do is we can rewrite this x squared plus 10x plus 16 by its factors, x plus 2 and x plus 8. And so this and this are the exact same things. There's no difference. It's just a different way of writing it. Remember, if we multiplied these out, we would get that trinomial. And this was equal to 0. So I'm going to rewrite this equal to 0. Now what this helps us do is using a product property called zero product property, we can solve this by splitting this into 2 equations. So we took this x squared equation. Now we can split it. We'll get into the zero product property later, but basically what happens is you can just think of this as 2 separate problems now. X plus 2 equals 0 and x plus 8 equals 0. So if I write this out as x plus 2 equals 0, and then over here separately I write x plus 8 equals 0. Again, I'm writing these equal to 0 because that's what was stated here. And we can do this because of something called ZPP, or zero product property. We'll talk about that later. But from there, all we're going to do is solve these separately. Remember, we expected up to 2 answers. So if I solve this one, if I want to get x by itself, how do we get rid of a plus 2? We just undo it with the opposite or inverse operation, subtract. So those cancel out. We're left with an x, and 0 minus 2 is negative 2. And the other possible answer is if I try to get this by itself, x plus 8 equals 0. To get x by itself, I'll subtract 8. And I get x is equal to negative 8. So these are the two numbers that I could plug in all the way back into this part here for x that would make a true equation. And you could always check your work. You could go back and say, well, what is negative 2 times negative 2? That's 4. Plus 10 times negative 2, that's negative 20. So 4 minus 20 plus 16, is that really equal to 0? Well, 4 plus 16 is 20. 20 minus 20 is 0. So we know that that would work. And we could do the same thing for the negative 8 and check it. Just to keep this video shorter, we won't. And so that's going to be kind of what we're going to do today, is we're going to look at an equation, like a trinomial, x squared plus 10x plus 16. We're going to break it into its factor parts, x plus 2 and x plus 8, and then we're going to split it up. And this splitting up process we can do because of something called zero product property, which hopefully we'll have some time to explain at the very end. If not, I'll make a separate video explaining ZPP. All right, so let's take a look at another example so you can see, and then I want to show you maybe some of the things that happen that you might not expect. So let's look at a second example. Again, your goal is just to kind of watch and see if you can make sense of what we're doing. The directions are going to ask us to solve. Now remember, solving means find the x that's going to make this equation true. So if I had x squared plus 6x minus 40 equals 0, what are the x's that make that true? Well, when I notice I have a trinomial, remember again, trinomial, in my head I think, oh, I can like simplify that or factor it down into its multiplication into a binomial times binomial. And again, if that doesn't make sense, go back and watch the factor video so that way it makes more sense to you. But anytime I see this, I can rewrite it. X squared is x times x. Now I need the numbers that go in with the x, that if I multiplied these binomials together, I would get this as an answer. So we talked that the easiest way to do that is to say, well, what numbers multiply to negative 40? It always wants to multiply to that last number that combine to that middle number, so combine to a positive 6. This will probably be the hardest part today, is trying to think of those number combinations, and that's where using that sheet can help you. The sheet that we have listed from last week's lesson that said, what are numbers that multiply to 40? 1 and 40, 2 and 20, 4 and 10. And you would just go through that list and say, well, 10 and 4 would multiply to 40, but to get to 6, I would have to have a positive 10 subtract a 4. So my numbers are going to be 10 and negative 4. So I can write this as x plus 10 and x minus 4. So x plus 10 times x minus 4, if I multiplied it out, would give me back to this. And you might want to take a second to do it just to double check. But otherwise you can move on. So once we get ours factored, now we could just split it into two equations where we can say x plus 10 is equal to 0 or x minus 4 equals 0. And there is an important step kind of that I'm just doing without really explaining that. This only works if it's equal to 0. We can't split it up if it was equal to 6 or equal to 8. It's got to be equal to 0, and that's what the zero product property says. Just because of the length of the videos, we may or may not be able to talk about it. I hope I can at the very end. But now from there, after you split them, notice it just comes straight down. Now you just solve for x. So what gets rid of a plus 10? Minus 10. So if we subtract 10 from each side, you get x equals negative 10. Or I can add 4 on this one and get x equals 4. What you'll notice after doing a couple of these is once you get your factors, if your factor is plus 10, your solution is just going to be negative 10. If your factor is x minus 4, then your solution is going to be the opposite, x equals 4. So hopefully you start to see kind of that pattern where you can, once you get your factors, you realize your solutions are just the opposites of your factors. So with that said, let's look at one more example where it's not equal to 0 and what we would do there. And then if I have some time here, I'll just show you what ZPP means and why this all works so nicely for us. So last example is x squared plus 9x plus 12 equals -6. So one of the things I want you to notice is in this one, it doesn't equal 0. We didn't really make a big deal of it before, but this side here, for our method of solving to work, this side has to equal 0. And if it doesn't, our first step is to make it equal 0. Remember, the nicest part about algebra is if it doesn't look like you want it, you can always just change it around. So in this one, x squared plus 9x plus 12 equals -6. I don't like that -6. I really want it to equal 0. So if I want to get this to be 0, I need to get rid of this -6. Well, in algebra, how do we get rid of a subtract 6? You just do the opposite. We add 6, because what is -6 plus 6? It's 0. But with everything, to keep it equal, we got to make sure if we add 6 to the right-hand side of the equation, we're also going to have to add 6 to the left-hand side. Now, when I go to add 6, I have to add it to its like term, so it's not like an x squared, it's not like a 9x. A 6 is just a regular constant, so I'm going to add it to the 12, which is also a constant. And now I'm going to rewrite my equation. I have x squared plus 9x, 12 plus 6 is 18, and -6 and 6 cancel out. So now my right side equals 0. That's really, really good. That's what I wanted. Now I can just go and do the problem again by looking at it and saying, well, can I factor it? Can I break it down? Well, x squared is going to be an x multiplied by an x. Hopefully that makes sense. And then I got to think of the numbers that are going to give me the combinations of 18 at the end and 9 in the middle. So can you think of, while I'm writing this, numbers that multiply to 18? So just think about all the numbers you know that multiply to 18. Do any of those combinations add to 9? 1 and 18 wouldn't, 2 and 9 wouldn't. What about 3 and 6? By the way, if you said 6 and 3, order does not matter here. But let's say we get 3 and 6. X plus 3 times x plus 6 is the same as this. So that's why I can write it there, because if I multiplied this out, it would give me this answer. And so I can just rewrite it this way. I like rewriting it this way because now I can split it up into two easier equations. X plus 3 equals 0 or x plus 6 equals 0. And then I just solve those separately. And I'm just going to solve each of those separately. So let's solve the left-hand side. I want to get x by itself, so I subtract 3. And I get x is equal to -3. Or if I say x plus 6 equals 0, I could solve that by subtracting 6. And I get x is equal to -6. So there's 3 examples that kind of walk through. All these are kind of done the same way. We start by making sure it's equal to 0. So step 1, just make sure that your equation says equals 0. Our first couple did equal 0, so it was no problem. When we started, it was equal 0, so we could go to step 2. Step 2 is factor this. So we're going to factor our trinomials using our factor x method, breaking it into 2 binomials, numbers that multiply to 18 and add to 9, or whatever that happens to be the problem. Then we get x plus 3 and x plus 6. Because of the zero product property, it basically says if I have 2 things multiplied together that gives me 0, I know one of those 2 have to be 0. So I know my answers could be x plus 3 equals 0 or x plus 6 equals 0. Then I just solve there. So hopefully that made some sense. We have another lesson up to this week. We have office hours posted, so if you guys do have questions, please stop by and see us. Yeah, that's it. Hopefully it works out for you guys. Talk to you later.